All right, so welcome to this presentation. I'm quite excited to be here. The first time and only time until now that I came to Australia. I was 17 years old. I'm not going to tell you how long it was. I'll let you guess. But it was a long time ago, and so apparently you guys built a lot of buildings since then. So I still see the bridge and the Opera House, but apart from that, I don't recognize much. But it's really good to be here. I'm really happy to be at NDC and talk to you about MVVM Light, about building cross-platform application, truly universal application. That's a little bit of a jab at Microsoft, who incidentally is my employer now since last year, so I need to be careful what I say. Nonetheless, it should be a fun hour. So my name is Laurent Bugnion. I work, like I said, for Microsoft. I'm what they call a cloud developer advocate. And my team is a relatively large team. We are about 65 people now. Our goal is to advocate for Azure, like the name says. So basically, we go around the world. We show people how to build applications with Azure, how to take advantage of our services. We also create a lot of online content, videos, articles, all kinds of things. And so if you are interested in checking what my team is doing, you can go on Twitter. We are actually quite active on Twitter and on different spaces. We build samples. If something is blocking you in Azure, don't hesitate to come to us. My particular focus, or my particular expertise, if you want, is around client application development, so especially .NET. In fact, tomorrow I will have a session about .NET Standard, .NET Core. So in case you're interested to see something else, you can check it out. And yeah, it's a pretty interesting team to be a part of. So in this session, we are going to talk a lot about client application development. And I'm sure you already saw this picture before. It's a picture that Microsoft has been showing when they talk about those so-called universal Windows applications, Universal Windows Platform, UWP. And it is, of course, a pretty good deal. You can build one binary, and then you can deploy in a large number of form factors of devices, all the way from phones, well, not so much anymore these days, but some people still use them, and of course all the way to Xbox through laptop. We have the tablets. I don't know if you saw the Surface Go. It's a really nice device. It's about iPad size, but it has a nice keyboard. It's a full-blown laptop, so you can actually run Visual Studio on it if you want. You have laptops, you have desktops, SurfaceHub, heavily multi-touch devices, and of course even HoloLens, so you can actually put those applications on HoloLens. So it's a good deal, but of course if you go mobile, then you have to consider iOS and Android, and this is where Xamarin is going to help you, and also architecturally speaking, I would say the Model-View-ViewModel pattern is going to help you as well, like I'm going to show you in this hour. So let's do a quick reminder, because really architecture is important when you do cross-platform applications. So what is MVC? What is MVVM? Where does it come from? MVC is a very old pattern, started around 1984. That's usually the place where I ask people who was not even born in 1984. Yeah, we have a few, right? OK, so the pattern is older than you. It's not older than me. I was 13 when it was created. Now I disclose my age. I said before I wouldn't do the math, right? But now you know, I'm 47. And so MVC started with Smalltalk. Smalltalk was a really awesome framework. It was kind of the first WYSIWYG, so you were really designing on the designer surface, deploying this to a computer, and it was also the first truly object-oriented language. And so they were using MVC, and so in MVC you have a model. The model is wherever the data comes from. These days it's often a web service, a web API, maybe a database somewhere. Could be the device itself, right? If you have a device with a GPS sensor, for example, you're walking around and then you have some events, some data coming from the device itself. So that can be useful. Then you have the view, and the view is what the user is actuating, what the user is interacting with, what the user is looking at. And then in the center, you have this very important object, the controller, which is doing a lot of things. It's orchestrating the whole thing, if you want. And so it's going to react to events from the view. So whenever the user is typing something or tapping on a button or doing these kind of things, it's also going to update the view Okay, so whenever something happens, it has to translate that to something in the view so that the user can take advantage of that. And it's also going to interact with the model, updating the model, reading data from the model, and also reacting to events from the model. For example, like I said before, when the user is walking around and then the GPS is raising events. So this pattern is very, very popular for client application development these days. We still use that primarily, be it in Android, native iOS, Xamarin Android, Xamarin Forms, Windows, etc. Okay? So if you consider, for example, in Windows, the view is often XAML. It is an XML-based, a markup-based language. All right? In iOS, we have those storyboard documents, which you open in the designer, but under the cover, those are actually XML, again, markup. And in Android, we have also XML. Why XML everywhere? Well, simply because XML is a good language to interact with a visual designer, with a tool, okay? And it's also human readable, so you can also edit it by hand if you want. I know in XAML, for example, for Windows, we usually switch between the designer and the text editor quite often, all right? Now for the controller, usually in Windows, in Windows, we do that in C#. We call that the code behind, okay, the .xaml.cs. And then in iOS, they call it a controller. It's not very original, but it is very descriptive. And in Android, we talk about activities, sometimes fragments also. It's a little bit like a user control if you want. So basically, it is where you handle the events and where you actualize the view. All right. Now, in MVVM, we don't get rid of the controller completely. What we are going to do is reduce its importance. We are going to make it smaller. Okay, I'm going to explain to you later why. And instead, we add an additional layer called the ViewModel layer. Okay, and this ViewModel layer, really the main difference between MVC and MVVM, if you want, is the way that the layers interact together. And in MVVM, we are going to use data binding for that. We'll talk more about data binding in a moment, but quickly said, data binding is like a relationship between two properties. You have a source property, a target property, and so if the source property changes, the target property is also going to change, all right? And so typically, the source property is in what we call a view model, and the target property is in the view, and so you update the view like that. And this happens pretty much automatically, okay? Now in MVVM, we also use something called a command. Command is a way to bind the view to the view model, from the view to the view model. So for example, when the user taps a button, through the command, it executes code in the view model. All right? Cool. So why do we even want MVVM in Xamarin iOS, Xamarin Android? It's a good question, because I told you that the Model-View model pattern relies quite heavily on data binding. And we don't even have data binding in Android native or in iOS native. So if we want to use data binding, it means we have to add data binding to those platforms, and it's an effort. Okay, in Windows, it's kind of a no-brainer because it's here. In Xamarin Forms, it's here. In Xamarin iOS, Xamarin Android, not really. So when I started doing the port of my open source library MVVM Light to Xamarin, I had to ask myself, is it even worth it? Am I going to do that or not? And after a lot of reflection, I think it is worth it. So if we consider the view again, right, we have on top, we have the view, some kind of markup, some kind of XML. And then we have the controller, all right, code behind, activity, etc. And this is really where the problem lies. Now, the controller mostly cannot be unit tested. Why? Because you are going to interact with some UI elements. Okay, so you're going to have, for example, a text view, and then you want to make sure, you want to assert that the text property of the text view is equal to a certain value. That could work. What doesn't quite work is clicking on a button, for example. Okay, in some frameworks, it kind of works, but it's really cumbersome. On others, it just doesn't work because you need a view context for the view element to actually work. So basically, unit testing these kind of things is really, really complicated. Okay, so it's not great. Even more important, probably, this object cannot be shared. And again, it's because of those UI elements. If you have an Android button and you put it into an iOS application, it's just not going to build. Okay? In iOS, they use UI buttons. They don't use Android buttons. So it just doesn't work. On the other hand, what you put in the view model is going to be unit testable, and it's going to be also shareable, mostly because we abstract those things and we use properties which can be asserted, okay, like text properties, integer, whatever, I mean, these kind of values, or we use some abstractions also, which I'm going to show you in a moment. Cool, so in fact, what we try to do, we try to go from a classic Xamarin model, if you want, where you are going to share easily the model, which can be already quite a lot of code, right? It can be maybe 50% of your app. It's already not bad. But on top of that, you're still going to have those silos, iOS, Android, and Windows. And what we try to do with MVVM is reduce the amount of code that cannot be shared. We're going to transfer that code into the view model, and then we use data binding to glue those layers together. OK, so I'm going to show you a demo. And for the demo, what I'm going to do is take an Android application which was developed with MVC, and then we are going to convert it to an MVVM application. And before I do that, I'm just going to try to restart the application on my phone. My phone is kind of causing some issues here. And I would like to demo this application to you. So I'm just going to uninstall it and restart it from here. Voila. OK, cool. So this is Visual Studio. OK, and here in Visual Studio, I have this application which I created. It's a classic Xamarin Android application. You see the activity here. There is somewhere an XML file with a UI. And what we are going to do is, first of all, understand what this application does. So I have a button, and I have a text view, very simple app. And then when the button is clicked, we are going to show the text, please wait. We are going to instantiate an HTTP client, and then we are going to connect to this URL. Now, this URL is my YouTube channel, my private YouTube channel. And I fly drones in Switzerland or all over the world. I didn't take it here for reasons. But here, this is about an hour away from my place. And as you can see, you know, when you have a YouTube channel, what do you want to know? You want to know how many people are actually looking at your videos, right? So I have 866 views on this one. It's actually not bad. And of course, my first move in the morning when I wake up is check how many views do I have, right? Understandably. So I want to do that from my iOS phone, from my Android phone, from my Windows device. And it changes all the time, right? I mean, in 1 week, I can have, I don't know, 2 additional views, which is, oh my God, it's absolutely fantastic. So you have to keep track of that. So what this application is doing, it's going to actually download the HTML, which is a horrible idea. Don't do that. And then it's going to parse the HTML. OK, I know. I see someone who's like, oh my God, what is this guy doing? I know. It's like a super simple example, right? So in practice, you would go to APIs. Google has APIs for that. OK, here I'm just doing some HTML parsing. Now, HTML parsing is a horrible idea. You don't want to do that, and especially not 3 times. OK, so I'm going to take advantage of Xamarin so that I can do this 1 time, and then I don't have to touch it again. All right. So how can we make this application a little bit better? First of all, I'm going to add MVVM Light to that. And to do that, I can go in NuGet. And I just recently released the .NET Standard version of MVVM Light. In fact, tomorrow at 3 p.m., I believe, I'm talking about this adventure, if you want. It was actually fairly easy. And so if you're interested to know what it took me to do the conversion from Portable Class Library to .NET Standard, come to the session tomorrow. And I'm going to show you. So here I'm going to look for MVVM Light, and I'm going to take the so-called STD10, so .NET Standard 1.0 version, which I'm going to add to my Android application. And basically, this is just going to help me be a little bit faster, OK? It's not necessary absolutely. It's not totally crazily necessary to do that, but it's just going to help me a bit. OK. Now, it adds, as you can see, a few assemblies, OK? But it also adds a folder called ViewModel. And inside this folder, I have a main ViewModel and a ViewModel locator. I'll show you more about those files in a moment. OK, and now I'm going to add a data library, which is going to be the library that I'm going to share between all my platforms. Because in the end, this application is going to run on iOS, Android, and on Windows. So to do that, I'm going to just add here a new project. And I'm going to take a .NET Standard class library. I'm going to call that data. And then I'm going to transfer the ViewModel folder inside the data class library. And the reason why I do that is that everything I do in the ViewModel folder is going to be shared across my platform. So I'm increasing the amount of code which is being shared. OK? Good. Now let's remove this class. And now I'm going to move also the model code. OK? The model code for me is the code which is accessing YouTube and doing the parsing. So I'm going to add a folder which I call model. All right. And then inside there, I'm going to put a class. Actually, I'm going to start with an interface. So why do I want an interface? It's because I want to have the flexibility of switching implementations as I go. And you'll understand later why I do that. It's mostly for testing purpose. OK? So here I'm going to add an interface, and I'm going to call that iYouTube service. Voila, let's make that public. And then I'm going to have one method in here, which is called refresh. And as you can see, it's a task of string, so it's going to be an asynchronous method. All right. Now I need an implementation for that. So let's go and add a new class. And I'm going to call that YouTube service. All right. Public. And then I'm going to say this implements iYouTube service. I explicitly implement here the method. And now what I'm going to do in this method is pretty much what I was doing before in the activity. OK? So I'm going to go into my main activity. I'm going to take this whole bunch of code here. So this is the parsing that I showed you before. And I'm going to put this here. I'm going to say, all right, add the using. This is a waitable, so I need to say this is async. And then instead of assigning directly, I'm just going to return the parsed HTML. So now I have the same thing that I had before, but this is code that I can now share with iOS, Android, and Windows. So that's good. All right. Good. So now the next step is to take care of the view model. All right. So the view model is going to be used to wire things together with a view, if you want. So here in my main view model, I'm going to add a property. And so before, if you remember, I was assigning the result of the parsing directly to my text property of my text view. Here, I'm going to put that result into a text property. And then I'm going to use data binding to update my UI. All right? So when you install MVVM Light, you install it through NuGet. But there is also an extension for Visual Studio. So if you go to Extensions and Update, you see there is here MVVM Light for VS 2017. And this adds a few utilities to Visual Studio, notably some snippets. So if I type MVVM now, you see I have a list of snippets which are going to make me go faster, basically. So for example, I'm going to say, OK, I want to add INPC. It's an iNotify property change method. It's a bindable method, a bindable property, an observable property. All right? Using the set method and the lambda expression, I'm just going to show you how that looks like. OK? So basically, this is what it is. Now I can just tab through to fill the field. So I'm going to say, OK, this is a result property. This is a string. And I need a field for that. And I'm going to initialize that to nothing yet. And like this, I have something which is bindable. Now, in order to how should I say, in order to trigger the binding, I need to raise the property change event. So this method set is doing that. But in order to do that, it needs MVVM Light. OK, so I already added MVVM Light to the main application. Now I need to do that for the data library as well. And by the way, since we are here, we are also going to add another project, which is a unit test project. I kind of forgot to do that. So let's add here a unit test project. In that case, I use unit test for .NET Framework. You could use NUnit, XUnit, whatever unit you prefer. Voila. And so now I'm going to just say, OK, those MVVM Light libraries which I'm using in my main application, in the Android application, I also need them in my class library and in my unit test project. So again, I go to the NuGet package manager here. I'm going to check what is installed. And as you can see, there are two packages which are installed for MVVM Light. There is a full one, and the full one has a dependency on the libraries. So when you pull the full one, which installs also the ViewModel folder, some scaffolding if you want, okay, you also pull the libraries. Now, of course, in my data class library, I just need the libraries only, okay? I don't need the scaffolding because it's already there. So I'm going to add the libraries to data and to unit test. And then I'm just going to confirm, accept the license. And now I'm ready to go. All right. Good. So now if I go back to my main view model, now you will see that the set method is known. So this method is basically, it's a method which comes from MVVM Light, which is part of the ViewModel-based class. And the ViewModel-based class is an observable object which you can bind, which you can data bind against. Okay. Good, so now I have this property. Now the next thing I need to do is add a command. And here I'm using the MVVM R snippet, MVVM relay. All right, relay command. Relay command is an implementation of iCommand. So basically it has everything you need when you click on something to execute code in the view model. And here I'm going to say, OK, this is called refresh command. Voila. I'm going to add the namespace. And now inside this refresh command, what I'm going to do is set the result property to please wait. Okay, that's something I can unit test, for example, if it's necessary. Then I'm going to call refresh on something which is called underscore service. We still don't have it yet, but it looks very much like an iYouTube service, right? Remember, I had the refresh method there. And then I'm going to catch an exception. And if there is an exception, I'm going to assign the message of this exception to my result property, which again is something I can unit test. Okay? Okay, this is a waitable, so I need to make this async. And now, basically, my data library is, my main view model is ready, except that I still don't have this underscore service. So underscore service, like I said, the refresh looks very much like the method I had before. It's an iYouTube service. How can I make sure that I always get an iYouTube service when I'm inside my main view model? Well, one way to do that is to say, every time that you create a main view model, I want an iYouTube service, wherever it comes from. And then I'm simply going to save that equals service. All right? And somebody has to be responsible for that. But it's not the main view model. I don't care who. All right? And also importantly, I don't care about the implementation of the iYouTube service. Right now, I only have one. I have the implementation which goes to YouTube and get it. But later, we are going to have multiple implementations. OK? Good. Now, of course, I need to save this. Voila. And now I'm ready. All right. I have one thing which is missing is really who is going to take care of passing this iYouTube service to my main view model. And in the MVVM Light framework, I would say we like to use something called the ViewModel Locator to do that. So basically, it's an object which is used to kind of prepare stuff. Instantiate services or declare services, register services, maybe prepare whatever is necessary. And then it's going to also expose here a property for the main view model. So we expose properties for like the major view models of the application if you want. So what I'm going to do here, I'm going to use this object called simple IOC. It's an IOC container. All right, I'm going to use dependency injection. And this object also comes from MVVM Light. And I'm going to say, OK, simple IOC.default.register. And here I'm saying every time that somebody in the application requires an iYouTube service, I want you to give him an instance of the YouTube service that I implemented before. Now, this line here is interesting because here I could have some switches. I could have some configuration. I could say, oh, if you are running in the morning, please take this implementation of iYouTube service. If you're running in the afternoon, please take another one. Or I could say, hey, if you're running in production, like on an actual device, please use my implementation. But otherwise, if you're testing, please use a test YouTube service. Why do we want a test? Well, for example, you see here I have this implementation. So I say, OK, if everything goes well, I want the result of the refresh method to be assigned to the result property. But if I have an exception, I want the message of the exception inside the result property. If I want to test that, I cannot really call YouTube and tell them, can you shut down for a while? I'm going to run my test, and then I call you back when I'm done, OK? It doesn't quite work. Apparently, they are very picky about these kind of things. So instead, we are going to say, hey, let's give another implementation of the YouTube service, which does it here on my machine without actually connecting to anything. OK? Good. I have one thing which is missing. I need to put some dependencies here, because now I have 3 different projects. So I'm going to add a reference to the data library into my main application. And I'm going to add a reference to the data library again inside the unit test application, just to make sure that everything's wired. All right, so now I have my view model. I have my view model locator. And you see what's happening in the view model locator is that I also register the main view model. And here I say, whenever someone needs a main view model here, for example, for data binding, you're going to get the instance from the IOC container. And then the IOC container is pretty clever. It's going to check and say, OK, do I have a main view model yet in my cache? OK? Oh, not yet. OK, I need to create one. What do I need to create a main view model? Well, let's go and take a look. Oh, OK, I need an iYouTube service. Do I have an iYouTube service? Oh, not yet. OK? Well, let's check it out. Oh, somebody told me every time that I need an iYouTube service, I need to create this YouTube service here. So then it will go and create the YouTube service, cache it, create the main view model, give it the YouTube service, cache the main view model, and then expose everything for the data binding. All right, that's kind of how it works. All right? Good, so now we have that. Now let's do the unit test. So what I want to unit test is this part here. I want to unit test that if everything goes well, I have the result in the result property. If not, I have the exception message. So to do that, like I said, I don't want to call YouTube and ask them to create errors for me. So I'm going to add a new class in my unit test project directly. And I'm going to call that test YouTube service. Voila. And this is also going to be an implementation of iYouTube service. All right. And this implementation is going to be a little bit special because I'm going to handle 2 cases. So the first case is if everything goes well, I'm going to add a constant so that I can assert. All right. It's a known value if you want. And then I'm going to add the refresh method. And in this refresh method, I say, oh, this has a task. I'm going to use this object. It's a utility class that .NET has, which allows you basically to execute an asynchronous method synchronously if you want. And the reason why I do that is that when you unit test executing asynchronously, actually you can do that now on most unit test framework at least, but sometimes it creates some side effects, so I prefer to avoid that. In my case, I don't need asynchronous because I'm not going to connect to the web or to anything, so I'm going to simulate it using task completion source. And then I'm going to say, OK, the result is set to this known value. So that's cool. But now I also need to test the error mode, all right? So I'm going to add another constant. This is the message of the exception. Again, it's a known value. And then I'm going to say I want to force an error. And to do that, I'm going to add a constructor to my service. And I'm going to say, if you give me here true, I'm going to save it. And whenever the refresh method is executed, I'm going to create an error. So let me just modify that, and then I'll show you in detail. Voila, so here I'm saying, OK, if the unit tester told me you need to create an error, absolutely, then every time that this method is called, I'm going to throw an exception using the well-known exception message. Otherwise, I'm going to use the normal result. All right. So now let's use that in my unit test. So this is a unit test here. I'm going to have 2 methods. One method for the success case. So here I say, all right, let's create a test YouTube service. I'm going to pass it to the main view model. The main view model is OK with that because it just needs an iYouTube service. It doesn't care about the implementation at all. All right? So he said, oh, OK, I'm happy. I have a refresh method. That's all I care about. And then I'm going to call refresh command. And then I'm going to assert that the result property is equals to this known value. And then the other scenario that I have is the exception case. So here in that case, I create another test YouTube service, but this time I give it true. I force an error every time. Then I'm going to call refresh command, and then I'm going to assert that the result is, this time, equals to the exception message. All right? So now if I build this and check the test explorer, again, you could use NUnit, XUnit, whatever you prefer. Here I'm just using the built-in .NET unit test runner. So if I build this, in a moment you will see my, my test methods coming up. And then I can quickly run them just to show you that it is working. So here we see, let me zoom a little bit. Here we see that we have those methods, all right? I can run all. And normally, if everything goes well, it should be green. Here we go, which means that basically my main view model reacts according to specification. So that's cool. Now, of course, if my main view model reacts according to specification, since the rest of the interaction between the view and the view model is automatically done by the data binding, it means I'm pretty much good to go. All right? Good. So now the last thing I need to do is wire my view model and my view using data binding. And so to do that, here I'm in a native Android application. So I'm going to use the MVVM Light data binding system. So let's go into the activity, and the first thing I need to do is add a class. And the reason why I add a class here is that Android doesn't have a concept of application class. Okay, in Windows we have app.xaml.cs. In iOS we have also an application class. In Android we don't have one, so I'm just adding one. And this is where I'm going to put my view model locator. It just makes it a little bit easier to find. Let's add here an instance of the view model locator, all right? And so now my view model locator is ready. I know where to find it when I need to do my data binding. Finally, in the activity, what we will do is remove this view code. So I'm just going to keep my text and my button. I'm removing the click event entirely. I'm going to use data bindings. I need to save those data bindings because the data binding is a loose coupling. It's a weak reference. And what's going to happen if you don't save them is that your application is going to work for a while, and then the garbage collector comes, and he finds all those bindings which are deliciously attached to nothing. Then it's just going to eat them. Okay? And then your application stops working, and you don't know why. So you need to save those. All right? And then after that, I'm going to add the data binding between here, the result property, we know that, on the main view model, on the locator, which is in the app, okay? And the target property is the text property of my text view. And finally, I need, of course, to trigger the whole thing. And so this button is going to be assigned a command. And this is a refresh command, which is on the main view model, et cetera, okay? Those methods, setBinding and setCommand, are extension methods which MVVM Light is providing. This is a binding framework that you get with MVVM Light. All right, I can show you the application running. So I'm going to try to connect to my phone if everything goes well. Seems to work. All right. So this is my physical phone, which is here. OK, you have the button. If I click, you will see please wait for a short while. And then after that, it connects. And then you see the 866 views. It's working. Now, the cool thing is that now this application can easily be converted into a cross-platform application. This is what I have here. It's another project. I have the same data libraries that I showed you before. Okay? I have the same Android application, but this time I also have an iOS application. And so if I open the iOS application here in the main, this is where I have my view model locator. And inside the controller, this is where I do my binding. So you see the list of binding. And then you see the set binding method between the result property, and this time, the target, it's a little bit small, but you see it's a UI label, so this time it's an iOS object. But the main code in my view model remains unchanged. All right? And similarly, we have in Windows. So here in Windows, we tend to do things in XAML. So here I have the locator, the view model locator inside app.xaml, and Here I have the refresh command, which is data bound directly in the XAML, and I have the result property, which is data bound directly in the XAML as well. I didn't take my iPhone here, but I do have the Windows version of the application, which works exactly the same. So now this small example, I hope you see that for this super small application, it was a little bit overkill. But the cool thing now is that I have a very, very healthy basis that I can start building stuff on. I have services, I have abstractions for those services, I have unit tests, I have data binding, which allows me to work very decoupled, okay? And so that's a nice situation to be in. All right, by the way, you get all the code. At the end, I have a resource slide where you'll get links to the repos. But let's go back to the slides for a moment and talk about abstraction, because abstraction is a super important concept when it comes to building cross-platform applications. So we did a little bit of abstraction here already. We have an iYouTube service, all right? And then we have two implementations, one for test, one for production, I would say. But abstraction is also important in the other direction, towards the view when you build cross-platform applications, because you don't do things the same manner on iOS, Android, or Windows, okay? Simple example is a dialogue. Now, showing a dialogue, it's always the same, right? You have a title, you have a description, and then you have one or more buttons. But if you check the code, it looks very different, all right? So in Android, Windows, iOS, and even in Xamarin Forms, we don't do things the same. In Xamarin Forms, this is going to be rendered to iOS, Windows, and Android, but it's yet another syntax. So of course, it doesn't really fly. Your view model, you want this code to be shared, okay? So the problem is the following. If you have the view model, and then if you interact with just one view, one platform, for example, I always interact with Android, then maybe I can call the code that I showed you before, the dialog code, directly from my view model. It's not a good practice, but it would work. But of course, if I add to that iOS and Windows, then it doesn't work at all, so we don't do that. One thing you can do is also use an abstraction. So you say, I have an iDialog service, all right? And this has maybe a show message method, for example. And then we inject that into the view model. We know how to do that because we did that for the YouTube service. Okay, we can do that for a dialog service also, for example, using an IOC container. Then we implement that. Now, that's a step which is a little bit annoying because you need one for iOS, one for Windows, one for Android. But the good thing is that once you have those, you can save that into a library. Then you don't touch them again. Or if you use a framework, MVVM Light, MVVM Cross, Prism, CSLA, all those frameworks have dialog services anyway, so you don't really need to do that. And finally, this is what happens, okay? Now, this pattern is also interesting when you do unit tests, because we saw that we want to unit test the view model, okay? And before I said, oh, my view model is going to save the message, the exception message in the result property. But sometimes you prefer to show that in a dialog, right, with a nice red border saying, hey, there was an error, okay? So that's something which is difficult to unit test because you can't really assert that the dialog has been displayed, okay? So that doesn't quite work. So again, we don't do that. Instead, we create a test implementation of the dialog service. This also has a show message method. And here what you can do is, for example, save the text that was passed to the dialog. And then after that, you can assert that. For example, you can test that the correct translation has been shown if you support multiple languages, or that the correct text has been shown, or at the very least, that the method has been called. All right? Good. So MVVM Light is this open source toolkit that I was using in my demo. Okay, I'm the creator. I started working in that around 2008, first publication in 2009. Back then, it was only for WPF. Then came Silverlight, then came Windows Phone, then came Windows 8, I guess. At some point came Xamarin to the mix. And now I support also UWP Windows 10. It has a set of libraries. Okay, we saw some of them, Simple IOC. We saw the view model base. There are a few more, Messenger, et cetera, et cetera. It also has some templates. So before I showed you, when you install in extensions and update in Visual Studio, you also get some file new templates, all right? So you can create an application directly wired and everything. And the snippets, we saw those also when you type MVVM in the code, and then it expands, and then like this, you can type faster. OK, I have about 3.3 million downloads, so it's pretty popular. This is what you have inside it. I'm not selling anything, so you can check it out for yourself if you want. But importantly, of course, it is open source. It has always been open source. It is under MIT license, which pretty much means you can do whatever you want except call me at 2 a.m. when you have a problem. That's about what the MIT license, if you want. It is part of the .NET Open Source Foundation. My good friend John Galloway is here also. He's the executive director. That's quite a title, but yeah, it's his. And I was very proud, actually, to be the first non-Microsoft project to be part of the OSS Foundation. It's really a good thing. They are helping basically promote usage of open source. It's not a Microsoft initiative, right? They have a lot of Microsoft projects, but it is independent, and they do a lot of good things. It is on GitHub, finally, some would say, because it was on Codeplex until they shut. I actually switched the light off when I transferred my code. GitHub has been good for me as well, but I kind of like Mercurial. That's why I stayed so long on Codeplex. Anyway, GitHub is pretty good for that too, and that's about it. All right, so let's talk now about data binding and understand a little bit better what is really data binding, because I told you it's like a crucial part of MVVM. Okay, if you go on a platform which doesn't have data binding, well, MVVM doesn't quite make sense. All right, so data binding is a relationship between two properties. So you say, OK, I have a source property, I have a target property, and then you establish a relationship. All right? But this relationship, well, it's going to keep them synchronized, but it's going to do that in a loose manner. OK, so we call that a loose coupling. In the contrary of having my target equals my source, which is a hard coupling. All right, here you have a loose coupling. What it means, a loose coupling, means that basically if the garbage collector decides to collect the source or the target, for that matter, the data binding is not going to oppose that. It's going to say, yes, that's fine. All right? So by doing that, you're going to prevent memory leaks. That's especially important because you know that in .NET, if you create an event handler, it's actually a hard coupling between the source and the target of the event. Okay? And so you might have some memory leaks because of that, while data bindings don't cause these kind of things. So the advantages of using MVVM and data bindings, there are multiple ones. First of all, because your objects are very decoupled, it's very easy to basically make smaller objects. Adding object is quite easy because you're not going to interfere with your existing objects. All right? So it's easier to maintain your application this way. Then it's also good for collaboration because typically you're going to have maybe one team working on the view model, one team on the model, one team on the view, all right? And then they don't really need to interact too much except when you connect the dots using the data binding. And this is through a clearly defined interface, so it's quite easy, all right? In my previous job, when I was doing consulting and working with a lot of clients to build client application, sometimes we were building the view before the services were even existing. Why? Well, we were simulating the data, and like this, the client could go to his boss and say, hey, look how nice the application looks. Can I get money to build the services now? Right? Sometimes you need to see something. Or we could also simulate some special cases, like what happens if, all right? What happens if I have a lot of customers? What happens if I don't have customers, right? Then that's not a good scenario, but it happens, all right? So this is pretty cool. Unit testing, we saw that. OK, now I'm able to unit test not just my model, but also my view model, which is a part of the view. So I'm unit testing a part of the view. OK, so I have more code which is safe. It's also better for sharing because, again, what is in the view model can be shared across the platform. Remember, this data library, it's a .NET standard library. I could use it in Xamarin iOS, Xamarin Android, in Windows. I could even use it on Linux in an ASP.NET application core. I'll show you how to do that tomorrow in my .NET standard session. All right? And finally, kind of as a side effect, but it's actually a very, very interesting side effect, it's also good for design. Why? Well, first of all, the designer in Visual Studio, I'll show you an example in a second, it's actually reacting extremely well to MVVM applications. You can see lists filled with design time data. And that's really cool because that allows you to check what happens if, right? If I have a lot of people in my application, is my list still going to scroll up and down fast enough? If I don't have any people, maybe I want to show a message saying, oh, it's not an error. Actually, your database is empty, right? If I go to my database administrator and I say, can you just remove all the customers because I need to test? Again, right, it's like the YouTube guy is not going to be happy. Here, I can simulate that very easily. And the simulation happens because I have my iYouTube service. I'm injecting that in my view model. So I could very well have a design YouTube service. And for example, I can test what happens if I have a very long message. Maybe I want to wrap it and make sure that it looks nice, et cetera, et cetera. So it's good for design as well. So the principles of data binding, we saw that a little bit before. Okay, we have this view model base. View model base is actually just an implementation of iNotify property changed. What it means is that every time the property changes, it raises an event, and the data binding is going to react to that. It's as simple as that. Of course, it needs to be raised every time, and that's why MVVM Light is providing you with those snippets and the set method. There are other ways to do that. There are, I don't know, there is some IL weaving where you can basically say, hey, every time that you build the application, just add this code in the intermediate language directly. That works. There are different ways to do that. I like to do that explicitly, but it's really up to you. This is declarative programming, which is interesting because what it means is that I'm kind of, when the page is created, I'm declaring all my bindings, but I'm not executing any code. I'm just declaring it, all right? And then the code is executed on demand. So that's a nice way to do things because you can take care of preparing your page, and then, oh, it's going to be executed on demand when the properties change. So that's cool. And so I have an example here. This is Windows XAML, which, by the way, could also be Xamarin Forms XAML on the left-hand side. On the right-hand side, you have the MVVM Light equivalent. So here I use a keyword. So in XAML, we use a binding keyword. Here I use a method, set binding. And then we have a source object, which is where the source property is located. In that case, the source property is the name of the selected item. And we have a target object, which in that case is a text block. On the other side, it would be a UI label or maybe a text view in Android. And then we have the property, which is a text property. Incidentally, the cool things with data binding is that those can be nested. So in that case, you see my VM.selectedItem, that's my view model, dot selected item in a list, dot name. And so if the selected item changes, my binding is going to reattach itself, reactualize itself. Everything's working fine. If the name changes, same thing. All right? So you can nest your bindings like that. It's pretty cool. Of course, there are disadvantages of bindings, and probably the main one is that they are a little bit slower to create and resolve. There is some reflection involved. In Windows, we mitigate that by using so-called compiled bindings. So there is an x:bind keyword that you can use in place of the binding keywords. Okay, the binding keyword is still there. Those are a little bit faster, actually quite a bit faster. But basically, it's still going to be slower than a simple equal. Okay, if you have my target equals my source, that's faster. All right. Those days, it's not so much a problem anymore because we have phones which are crazy fast. Okay, so it's not too bad. But sometimes if you have a very long list and each item in the list has like 15 bindings, well, I'm probably going to question your design, right? But it might be a scenario, and then maybe the scrolling up and down is not going to be as fast as you want. In some cases, back then in my previous firm, we built Twitter for Windows Phone. And I can tell you the first time that we scrolled up and down, it was a nightmare. So basically, we had to go back to MVC just for the list. Okay, that happens too. The other disadvantage, it's a loosely coupled system. And so it's a little bit more difficult to understand. There is some abstraction here. If your property, if you know that your property is changing, but the view doesn't update, well, there is a problem in the binding expression somewhere. And that's a little bit tricky to debug. So these days, it's not too bad because the compiler is going to help you. It's going to show you some errors. And so that's a lot easier. In the early days of WPF, you didn't get an indication. It was just plain XML. And then they added a data error, which was not crashing your compilation at all, but it was just showing in the output window. That was good. And now, basically, you pretty much see if there is an error. Also, you have IntelliSense on binding, so that's useful. All right, in terms of support, data binding is supported natively out of the box on Windows. Okay, XAML, Windows, WPF, Silverlight, Windows Phone. Yes, I said Silverlight. That's where we raise our fist. Oh, sorry. So Silverlight, Windows Phone, Windows Universal. It's also supported out of the box in Xamarin Forms. It is not, however, supported out of the box in Xamarin iOS, Xamarin Android, because natively Android and iOS don't know data binding. But you can add it using, for example, MVVM Light. CSLA has a binding package. MVVM Cross has a binding package as well. Interestingly, data binding is trending in HTML. That's kind of a nice, the snake that bites his own tail because they inspired themselves from WPF. The first to introduce data binding in JavaScript and HTML was Knockout, which, by the way, Steve Sanderson, the engineer who is behind that, is now behind Blazor. Blazor is awesome. It's like Silverlight, but the right way, if you want. Yes, yes. Very clever guy, and so he added data binding support in HTML and JavaScript, and then Angular, the Angular team saw that and said, oh, that's pretty cool, and then they did the same in Angular 1, Angular 2. So basically, data binding is a nice thing to have, and we have that on the web as well. All right, so I have a little bit more code that I can show you. Let me just, unlock my phone. Here we go. So there is this application. There is this application called Flowers, and this application is basically, it's on GitHub, right? You'll get the repo at the end. And what this is doing is basically a master details application, which is pretty much complete. There is some navigation, there are some messages going on. And the architecture is very, very similar. So you can see that there is a data library, okay? Inside this data library, I have my iFlower service. This defines a refresh method and a save method. I have an implementation here, which is connecting to a service on Azure. And then it's going to get some JSON. It's going to deserialize that. Basically, it is an API model, OK? I also have another implementation of this Flower service, which I use for design purpose. And now, what this does, it's going to create 20 flowers. Those flowers all have the same description. They have a different name, all right? And now the really cool thing with that is that if I open my XAML page, for example, the Windows 10 or the WPF page in the designer, you can actually see the list because it's automatically going to call the design flower service. Even better, you can actually edit that. So if I right-click here, edit additional template, edit current, now I can select, for example, the flowers here, and then I can do stuff. And this is all real time. You don't need to even run the application, right? For example, I can make it bigger. Voila, and then you immediately see the result on your list. OK, you can change the color, or I don't know, let's make it. I usually like to show the foreground. I usually like to show this ugly green here, et cetera, et cetera. So you can do that directly here. That works for Windows 10 and for WPF. Now, in Android and iOS, unfortunately, the Android and iOS designer, the native ones, are a little bit less powerful than this one. And so you can do that directly in the designer. But what you can do, remember this ViewModel Locator object where we do all our setup? Well, here you can say, if false design data is true, then instead of using the normal flower service like in production, use, please, the design flower service instead. And then you can run your app on your phone and then immediately see with design data how it looks like without having to connect to your service. So again, you can simulate special cases, which is quite useful. All right, another thing I wanted to show you is that this is using the exact same model for data binding than we had before. For example, here in the main activity, we have here the view model, all right? And then we have the command, and then we have, for example, this property called last loaded formatted, which is bound to this text view. Here I'm using something which I didn't really explain, but if you check the sample, it is basically binding an observable collection. So it's a collection which raises events when it changes to the list view. Like this, again, this is a binding. You don't need to do that manually. And I have exactly the same type of code in the iOS version. So if I go to my main view controller down there, here again I have the binding for last loaded formatted. I have the command, and here I have again this this data binding for the list view, for the table view in that case. So basically what it means is that my list is automatically going to be updated when things change. Now again, on my phone, I don't know why I can't really show you that in Android, but I do have the Windows version running. So if you go there, you can refresh, all right? It's going to load, you can check the flowers. There is a commenting system, so you can click here, say, hello, Sydney. Click save, then it's added here. And like I said, I wanted to show you on Android. Unfortunately, my phone is not cooperating. But basically, you can run it on your own and see how it works. It is pretty much running all the time, so that's cool. All right. Good. By the way, yeah, I told you there is also a WPF version. It's a little bit, it's not totally done yet. I need to work on that. But if I open it in the designer as well, it's also going to work and show you the list, the formatted list. So same principle applies in Windows 10 and in WPF. OK, I have 5 minutes to talk to you about Xamarin Forms. And Xamarin Forms, why do I reserve only 5 minutes to that? It's because really, it's just the same. It's using XAML as a front end. So for those of you who don't know, we create the UI once. Okay, before I had an Android application where I have one UI. I have an iOS application where I have one UI. We call them, I don't know, truly native or whatever what you want to call that. And then some C# code. Here in Xamarin Forms, we create the UI once, so you have a little bit less control on the UI. But of course, the advantage is that you also have less work because you create the UI once. It's going to be rendered on iOS, on Android, on Windows. Okay. And so this is using XAML as a front end. It's almost the same then on Windows, okay? The reason why I have the almost is that there are a few words which are not quite the same, all right? We use binding context instead of data context, but mostly it's the same, all right? So if you know Windows, you'll be super familiar with that. There is a little bit of reference here. And so I can also show you quickly the same application, the same flowers application in Xamarin Forms. And so you see, this is exactly the same structure. I have my data, which is exactly the same data than I saw before, okay? I have an Android, iOS, UWP application. Those are just my head project. I'm almost not going to do work into that. Where I do work is really into this forms project where I have my main page.xaml. I have my app.xaml. It looks very much like Windows. And if I check my main page.xaml here, you see that I'm using binding. I'm using a binding here. I'm using a binding to the command. And so basically, same thing than we had before. Same principle. And again, the application is running. So if I open it here, voila, this was the native app. And this is the Xamarin Forms app. You see the UI is a little bit different because here I'm using a UI which fits on Android, on iOS, on Windows. Here I'm using a Windows native UI using the command bar. But basically, the application runs in the same manner. If I click here and click on C command, you can see the command that I just entered before. So basically, it is running, right? I'm not lying here. All right, so that was it. Now, all this code is available to you. Conclusion, I would say MVVM makes sense, in my opinion, because you're going to increase the surface of code that you share. Okay? You're going to make it more unit testable, so you have a good feeling of security when you run your unit tests. It's going to be better for collaboration between your teams because of the abstraction of the data binding, which is a loose coupling. And it's going to help you abstract the differences between the platforms so you can have more code running everywhere. All right? It's also increasing the designability, especially on Windows with Blend or the Visual Studio Designer. A little bit less in Android and iOS, but it's still useful to sometimes just toggle design time data so that you can see a nice UI where you can simulate some special cases, all right? MVVM Light is a toolkit. Again, it's not the same toolkit or framework out there. There is MVVM Cross. There is Prism for Xamarin Forms, very good framework also. There is CSLA, for example, if you do more enterprise. MVVM Light is simple to use, speeding up repetitive work. It's pretty established as one of the main ones, I would say, recognized by Microsoft and Xamarin. So I work quite a lot. Well, now I work for Microsoft, but before I didn't. But I was already collaborating with them quite a lot. And I want to plug the Sydney Mobile.NET Xamarin developers. All right, so Alec Tucker is the guy to contact if you're interested. They meet every second Tuesday of the month in the Microsoft Reactor. I don't know if you have been. It's a very nice space that Microsoft has. It's just about 10 minutes from here by foot, okay, on York Street. I went there yesterday or the day before, I forget, and it's really nice, all right? So they meet there. There is also coffee and everything. So if you're interested in Xamarin, go and visit them. Seems to be a very nice team. And here you have some resources. All you need is at gslb.ch/ndc-sydney18-1, because tomorrow I have a -2. And so tomorrow my session is about porting MVVM Light to .NET Standard. We're not going to talk about MVVM Light so much, but much more about the port itself, .NET Standard, .NET Core, what it is, why you should probably adopt it. I hope to see you there. In the meantime, I'm going to stick around for questions. Thank you very much for your attention, and have a great evening. Thank you.